Good morning, students. Now we'll study more and more about these trigonometric functions so that it may be clear to everyone. Okay, so let us see what we more can study in this. Now we have trigonometric functions. We'll continue with the graph in previous video which I was making, but now we'll explain to you in detail. Like we see how 0, here we have pi by 2, here we have 2 pi, no, we have here pi, 3 pi by 2 and 2 pi. Now we all know the difference between the degree and the radian. See, so now we can also know how to convert degree into radian and radian into degree and vice versa. Now we'll see. See, we have already learned about the coordinates in class 9th, coordinate geometry. Okay, there we have ordinate and abscissa there. Okay, we have 4 quadrants are there. First quadrant, we have second quadrant, we have third quadrant, we have fourth quadrant. But here we'll talk about the trigonometric ratios. Okay, we'll talk about the trigonometric ratios. Now see, I'll write one thing. All schools to college. Okay, all school to college. Now this is we can say a code which we can easily remember or in our mind. Now all means in first quadrant all trigonometric ratios are positive. All trigonometric ratios will be positive. In second quadrant we have only what we have only sine or cos, sine or cosec, sine or cosec, sine or cosec. In third quadrant will be tan or cot will be positive, and in fourth we have cos or sec, we have positive. Now we don't have any confusion that the reciprocal of sine is cosec, reciprocal of tan is cot, reciprocal of cos is sec. Okay, so in this quadrant we are able to know that in first quadrant all trigonometric ratios are positive. In second quadrant we have sine or cosec is positive. In third quadrant tan or cot is positive, and in fourth quadrant cos or sec is positive. Okay, now we have only 6 trigonometric ratios. Okay, now we'll discuss about why I have written this 0. It begins with 0, then 90, 180, 270, 360. Again it moves further and further and further, because they will ask in numericals to find the values. But before going to that, we must know that more formulas. Sine 90 minus theta will be cos theta. Sine 90 minus theta is cos theta. I am talking about the first quadrant here. So 90 minus theta will be first quadrant, here all are positive. So sine will also positive and it converts into cos theta. Okay, so more thing we need to learn about is that only at pi by 2 the trigonometric ratio changes. Only at pi by 2. We can't change at pi. For example, if I use sine pi minus theta, I am talking about second quadrant. Here sine is positive, so sine will be positive and sine theta will be there. Because at only, if I write here cos pi minus theta. What will happen? Second quadrant I am talking about. Here cos will be negative because only sine is positive. So right here it is minus cos theta. Okay. So that is how we can easily solve such kind of numericals. We'll solve numericals, but before we must know these values, at which value the ratio will change. So we must know that the ratio will change at this pi by 2 or 3 pi by 2, but it will not change at pi or 2 pi. Okay, so lot of things are there which they change. So now sin 90 minus theta is cos theta. If I write sin pi minus theta, it will not change. It is in second quadrant and second quadrant. So pi minus theta. Okay, I am talking about second quadrant. Here sin is positive, so positive, and sin will not change because sin will change at only at pi by 2 minus theta. Okay, so the first formula we must know now from this is sin pi by 2 minus theta. First I will let you know at what ratio these will change. So after that we'll move to the more formulas. I hope now it is clear to you that in which quadrant which ratio will change at pi by 2 only. Okay, if I use a pi or some else angle at 2 pi, if I say sin 2 pi minus the here, so I am talking about fourth quadrant. So it will be negative because in fourth quadrant sin is negative. One more thing, pi I am using, 2 pi I am using, so it will not change. It will not change. For example, now I am taking about, if I am taking now 2 pi minus sin 2 pi minus, if I take which value I take? Pi by 3. So I am talking about, here it is, which angle I am talking about? 2 pi here minus pi by 3. That means if I take LCM here, 6 pi sin 5 pi by 3. Sin 5 pi by 3. See, we can easily identify this in which quadrant it will be, like sin 5 pi here I am taking. One more thing is, and pi I am taking here is 180 degree, not 22 by 7. You have to take care of this, that here pi value in this scenario is 180 degree, not 22 by 7. In other cases we take pi is equal to 22 by 7, but here I will take pi is equal to 180 degree. So if I put pi 180 upon 3 here, 3, I am talking about sin 300 here. Okay, so I am talking about sin 300, 270, and here it is 360. So it lies in fourth quadrant. See, we can easily identify in which quadrant the ratio is, then we can easily write its value by finding it. Okay, so now we know that its value will not change. Let us find its value. So it will be sin 2 pi minus 3. Here it will be pi by 3. I have already told you at pi it will not change. The trigonometric ratio will change at pi by 2. Okay. So likewise its value will be, what is sin pi by 3? Sin 60 root 3 upon 2. But I am talking about fourth quadrant, so it will be negative. Because in fourth quadrant only the cos and the reciprocal of cos is positive. So here sin will be negative. We'll discuss more numericals. We'll do more numericals here so that you able to easily understand how these value changes and what about this. But before going to further, let me discuss more numericals, more formulas, so that you easily able to but no, I think there is no need to cram. Okay, just remember by heart so that you can easily know the formulas in future also. Okay, because this is the maths. Maths is not for the one day we do. Okay, so first one is sine pi by 2 minus theta, and if I use cos also here, so what will be cos? Cos pi by 2 minus theta is equal to sine theta. I am talking about minus value. If I put something 30, 90 minus 30, 60 degree, 60 degree will be in first quadrant. In first quadrant, we know all the trigonometric ratios are positive. Okay, so from this we find that sine 90 minus theta is equal to cos theta, and cos 90 minus theta is also, that is sine theta. Okay, now we'll move to another formulas for this. Okay, we'll discuss these more formulas so that we can easily study and further. Now we'll move to second formula. Okay, so now see, we have sin 90 minus theta is cos theta. Now we'll use more tan 90 minus theta will be cot theta. One more will have cosec 90 minus theta will have sec theta. Okay, so now we got the formulas here. Sin 90 minus theta is cos theta, cos 90 minus theta sin theta, tan 90 minus theta cot theta, cosec 90 minus theta sec theta. Here I can use that cot 90 minus theta, it will be tan theta, and sec 90 minus theta will be cosec theta. Okay, so finally we able to know the formulas sin, cos, tan, cot, cosec and sec, how they are converted into the other trigonometric ratio when we apply the 90 minus theta. So these are the most important formulas, but we able to know from this graph. So we must have a good knowledge of this graph so that we can easily find the formulas of this. But we will study more formulas from this graph only. But before going to that, let us discuss more about the ratios form value. Like for example, what will be the minimum value of sine and what will be the maximum value of sine. For example, now we know the value of sine 0 is 0. Okay, now what is the value at sine 90? It's 1. Okay, so that is how we make the graph. Okay, so let us see. We'll try to observe that sine and cosec, sine and cos. Okay, how these forms looks like in a graph. 0, 90, minus 90. Okay, and cos is here. We'll move to the cos. 0, 90 and minus 90. Okay, now we know at sine 0 we have 0 value. Okay, so sine 0 is 0, but at sine 90 is a maximum value of sine, that is 1. So its graph will be like this, maximum value. Then it will move down. If I move to sine 90, it will be minus 1. So sine graph varies from minus 1 to 1. Okay, so that is how we can easily show the value. Okay, we'll move to it further. We'll tell you why I'm making like this. So it should be something like maximum. You have to show this. Okay, so here we can see we have taken only the minimum and maximum value, but in between we can take more values also. Okay, like now sine 0 is 0, sine 90 plus 1, sign in negative value minus 1. Okay, so we take like this. Now we can see here plus 1. Now 90 is there. We'll move to further all these values. See 0, 90. Then we take after 90 we can go to the 180. Okay, so 180 we have the value again, it's 0. Okay, then 180, then we move to the 270, 270, then we have 360, 360, then we have, so this by 90 it moves around like this. Okay, so it moves around like this. So its maximum value is now plus 1. Here it is, I am taking, if I am talking about, this will be pi. Okay, so 180 will it will be like this. 90 is there, plus 1, 0, 90, then 180, it's again 0, 180, then we move to the we have 270, then we have 270 is there, then we move like this. Okay, and for the cos also, okay, for the cos also we can see that the cos also we have now maximum value, like say cos 0 we have 1, so its graph will not look like this. Its graph will look like this. It is 0 will be here because it has maximum value. Okay, so its maximum value, so we'll see from here it will move like this. No, that will not move like this. For the sine. Okay, let us see. It will move like this. Okay, so it will move like this because we have 1 at cos 0 we have, then we move to the next value. So that is how. Now see, now we can make the exact waveform of sine. Let us try. Now we know here that is how the minimum value is minus 1 and the positive value, maximum value is plus 1. Okay, so 0 minus 1. So it will begins like sine 0 minus 1. Okay, see now what is given is maximum value is 1 at 90. We can see here it's pi by 6. Okay, then we have pi by 3 we have, here we have pi by 2. Okay, then we have after pi by 2 90, then we'll take the 120 and 150 is there. Okay, so we can take like this, that is 2 pi by 3, and here it is 3 pi by 2. Okay, now it's not only 3 pi by 2. We'll make it more clear to you now that it is the maximum value we have, that is pi by 2. Then we have after 90 we have 120 value. Okay, it will be 3 pi by 2. No, 3 pi by 2 will be, it will be 2 pi by 3, sorry, 2 pi by 3. Then we have after 120, then we have let the value 150. Okay, so 150 is there, that is 2 pi by 6. If I take this, now 150 will be what? 2 by 6. Now it will be not like this, so we can make it, if I want 5, right, it will be 5 pi by 3. So you can easily understand this. Now here will be pi. Okay, from where it will fall. same line it floats like here, this also. So my shape is going like this. Okay, so now this is the maximum value. Here I got the minimum value, that is minus 1 here, that is at 3 pi by 2. 3 pi by 2, 270. Okay, just I am taking the gap of 30 degrees. Okay, 30, 60, 90, 120, 150, 180. Okay, from 180, after that I will go to the further values. Okay, so like this we can do it, like 7 pi by 6 if I take. Okay, that is 210. After 210 we can move to the 240, then we move to the 270. So like this it goes till I am making here is 2 pi, that is 360 degree. Okay, so 360 degree, that is at 360 degree again its value will be 0. So that is how we try to make it. Okay, so what it is given, if I use here 4 pi by 3, so 4 into 180 upon 3. Okay, yes, so here will be 4 pi by 3. Okay, so that is how we can know. I have taken a 30 degree angle difference. 30, 60, 90 is a maximum value, right? I have taken the 120, 150, 180 is then I am going to the, so this is a sine form. Sine waveform we can show like this, that at a maximum value will be at positive 1 and the minimum value will be minus 1. So maximum value will be at 90 and the minimum value will be at 270. Okay, so after 270 I can goes to 300. Okay, so how will write the 300 here? Yeah, I will write 300 here like this. Okay, 180 upon 6, 30. No, it will not be like this. If it is double that, so here I will use this 3, right? So it will be 5 pi. Okay, it will be 300, right? Okay, so that is how it moves. On 3, 60, 5 pi by 12. Okay, so that is how they move, like it is 7 pi by 6. Okay, so 5 pi by 3, that is 300. After 300 I can move to 330. Okay, so how will be 330? I think 330 will be 11 pi by 6, because 11 into 180 upon 6, 30, 330. So 11 pi by 6 and then 2 pi. So now we can easily make the sine wave form. Okay, how you can see the maximum value is minus 1, that is at 270, and the maximum value will be at 1, that is at 90 degree. Okay, so lots of things we can do like this. This is of the sine ratio, sine theta. Now we'll move to the value that is cos theta. We'll try to see how the value of cos we can make. Okay, where it's the maximum value and where it's the minimum value, because we all know that maximum value is at 0. Okay, because cos 0 is 1, but at cos 90 it is 0. So it's this graph will be different from sine graph. Okay, so we'll make like this, that is like this, because now it will be changed totally. It will be changed totally because 0 value of cos comes at 90. 0 value of cos will comes at 90. Okay, so that is how we'll make. Let us see how we can make it. Now see the value of cos. How we'll make the graph of cos will be like this. like it is pi by 2, 90. Because 90, the value of cos will be 0. Okay, 90. Now here I am taking pi. It's pi, it will be minus 1. Okay, so it is 1 minus 1, 90. So 180. Then again I am taking 3 pi by 2. So we can see here that how the graph of cos varies, because the maximum value of cos we have taken 1. Okay, now so here I am taking its value is 1, positive 1. It's the maximum value. Okay, we have at cos 0. Now as cos 90, its value will be 0. So now after cos 90, if I move to this one here again, okay, so you can see here cos 180 will be minus 1, and then again cos 270, it will be 0, and after cos after reaching this value, now we can move this like this. So this graph shows, so at 0 value will be its 90, then 180, 270. After 270 will move to what? After this is value is 270 I have made, then again it is I have after 270 will be 360. So moves like this. Okay, so we find that its value will be maximum at what? So that is how we make and how the graph of cos varies. Okay, so this is the graph of sine and cos. So you can see how the maximum value of sine 90 is 1, and the minimum value we can see here. If I see that is a minus 1, it goes to at 270. Okay, so like how it graph goes, and for cos also we can see at the 0 value of cos will be at 90. Okay, and the maximum value will be at of cos is plus 1, and the minimum value will its value varies from minus 1 to 1. So we show graph like this. Now again 180 it will be minus 1, then 270 it will be 0, 360 it will be plus 1, then again like moves. So you can see that how its value changes. Okay, so now we find this, that if I am not wrong in this, that sine value varies n pi. Okay, sine n pi. Okay, so sine n pi I can write here multiple of pi, that it will be 0 value, and here also if I goes for cos, it will be like this, pi by 2. Okay, cos value will be 2n plus 1 pi by 2 and sine n pi. Okay, so it is move like this, because if n is 1, 3 pi by 2. See, 3 pi by 2 it will be 0. So that is how it varies. Or 0 or cos theta I can take here, sin theta n pi, and cos theta will be written like this. We'll see and solve more and more numericals on these further. More formulas we have, and we'll move to the next section now. I hope it's clear now how this sine and cosine graph varies. Thank you.